Okay, what we are going to talk about in today's lesson is the Pythagorean theorem, which you guys have seen countless number of times over your math career. But what we're going to do is a little proof of the Pythagorean theorem, so you guys actually see why it's true. Maybe you've seen it before, maybe not, but I'd like to show you why the Pythagorean theorem is true. And then what we're going to then do is look at the converse of the Pythagorean theorem, which you probably haven't seen before, and we're going to use that to classify triangles. So, if I asked you, you could most likely tell me what the Pythagorean theorem is. That's our a squared plus b squared equals c squared. But do you know why this is true? So on your little graph here, what I want you to do is draw a right triangle with legs of length 3 and 4. So similar to what I'm going to draw here. It doesn't really matter which one's 4 and which one's 3. And then connect those. So this one's 4, this one's 3. If we connect those together, I will tell you, since it's not directly on the coordinate grid, that hypotenuse is a length of 5. These three numbers, the 3, the 4, and the 5, are what we call a Pythagorean triple, which just means that these are integers that satisfy or make true the Pythagorean theorem. So 3, 4, 5, and there are many others. If you Google Pythagorean triple, you'll find lots of examples, but 3, 4, 5 is the most basic example. Just integers that make the Pythagorean theorem true. All right, so back to our little right triangle on our grid here. It says from each side of the triangle, draw a square. So I'll do that in a different color. So off of my side that's 3, a square will look like that. Off of this side that is 4 units, I'm going to go out 4 units to create the square. And then the hypotenuse is a little tricky because you're not right on. You can kind of estimate here what you think looks like a square. Okay, so we have squares off of each side. Now I want you to think about what the area of each of these squares is. Well, these two are pretty easy to calculate. You could actually just add up, count up the number of squares, or if you know the side of a square is 9, if the side of a square is 3, 3 and 3, you know that that area is 9. So the area of this triangle is 9. The area of this triangle, why am I saying triangle? The area of this square is 9. The area of this square is 16. And then if you know, even though you can't add up the squares, if you know that the side length is 5, you know that the area is 25. So let's think about the areas of these two squares, the 9 and the 16. What do you notice about those two compared to the 29? Well, obviously 9 plus 16 equals 25. So what this shows you is that the square of this leg, so the square, if we call that leg A, the square of that leg plus the square of this leg, let's call that B, is equal to the square of the hypotenuse, which is C. So this is just showing you that the Pythagorean theorem is true, which I'm sure you believed anyway, but this is showing you why. The square of one leg plus the square of another is equal to the square of the hypotenuse. All right, so let's look at some examples. You will not see any very basic Pythagorean theorem problems. I expect you to know that from middle school. So what we're going to be looking at in Pythagorean theorem are word problems mostly. Okay, So it says the two antennas shown in the diagram. Well, there's no diagram. We need to sketch that. So think about two antennas that you see along the highway, like two telephone poles. So here's one telephone pole, and here's another one. It says they are supported by cables 100 feet in length. So from the ground up to each antenna, those cables are 100 feet. If the cables are attached to the antennas 50 feet from the ground, so from the ground up to where the cable is attached is 50 feet, how far apart are the antennas? So I'm looking for the length from one antenna to the other, okay? Now, a couple things that we need to think about logically. If I'm putting antennas in the ground, I'm probably going to do it so that they're perpendicular. That would probably be the best way to build those, to have them be stable. So what we have here is a right triangle. Notice that I know the hypotenuse. I'm not looking for the hypotenuse. I'm looking for the length of one leg. So why don't we first find the length of one leg? You can either use A or B for the length of a leg. Just make sure, see your hypotenuse. So let's say that 50 is A and that we're looking for B. The hypotenuse is C. We are going to multiply these out. So 50 squared is 2,500. 100 squared is 10,000. Some big numbers here. Alrighty. What we are going to do from here is subtract 2,500. So B squared equals 7,500. And then we need to take the square root. Now, before you put that in your calculator, we are going to simplify the radical. Simplify the radical. So I have to go back to the internet or some other resources to remember this. We'll go through one, but this is something I expect you to know from algebra. So off to the side, 7,500 will break down into a factor tree. So factors of that are 75 and 100. Break it down until you get to pairs. So there's a pair of tens that I would pull out. 75 goes to 25 and 3. 25 goes to 5 and 5. So there's a pair of 5s. So I'm going to pull the pair of 10s out and the pair of 5s out, but I have that 3 left underneath the radical. And then I just multiply. So this is 50 radical 3. That 50 radical 3, remember, is from the middle to one antenna. So if I want to know the length between both of them, I would multiply that 50 radical 3 by 2. So the distance between is equal to 100 radical 3 feet. If you need help on simplifying radicals, Khan Academy is a good place to go. Good place to go. Let's look at another example. A baseball diamond is really a square because the distance between each of the bases is 90 feet. So think about a baseball diamond, but it's really a square. The distance between each base, there's home, first, second, and third, is 90 feet. And the angles are all right angles. How far does the catcher, who's at home base, have to throw the ball to the second baseman? So I'm looking for that distance. So what you might see here is that we've created a right triangle. And here we're looking for the hypotenuse, which is always across from the right angle. Start with your Pythagorean theorem. 90 and 90 are the length of both legs. So 90 squared plus 90 squared equals c squared. Square both of those values. That's 8100 and 8100. equals c squared. Add these two together, that's 16,200, excuse me. And then take the square root. Again, we are not going to write this as a decimal. We are going to simplify the radical. So off to the side, break this down. This breaks down to 162 and 100. So the 100 gives us a pair of 10s that we can pull out. Pull that out in front. 162 goes to 2 and 81. 81 gives us a pair of 9s. So the 9 is coming out. That 2 that's left over is underneath. So the 10 times the 9, this is 90 radical 2 feet, is the distance from home to second. All right, moving on here to the converse of the Pythagorean theorem. And what we're going to use this for is to classify triangles. So first of all, we look at whether or not a triangle is a right triangle. So if the square of the length of the longest side of the triangle, so the longest side here would be C, if the square of that is equal to the sum of the squares of the lengths of the other two sides, meaning if C squared equals B squared plus A squared, then the triangle is a right triangle. So basically, if your three values satisfy the Pythagorean theorem, it's a right triangle. So if we look at the first example, it says the triangles appear to be right triangles. Tell whether they are right triangles or not. So first of all, we have to decide which one is the longest side. Between 8, 7, and radical 113, radical 113 is the longest side. That's about 10.6. I do not want you using decimals. I want you working with the radicals. So once we figured out that, then we're going to take the square of 113. Is that equal? Notice I put a question mark because I don't know if that's equal. Is that equal to 8 squared plus 7 squared? On the left-hand side, radical of 113 squared. The square and the radical just cancel out. So 113, is that equal to 64 plus 49? Those are equal, so this means yes, it is a right triangle. It is a right triangle. On the second example, again, the longest side is 4 radical 95, so I'm going to square that. Is that equal to 15 squared plus 36 squared? 15 squared is 225, 36 squared is 1296. But now we have to think about simplifying that 4 radical 95 squared. Here's what you are going to do. You are going to take that exponent, apply it to the 4. So 4 squared is 16. Radical 95 squared is just 95. So 16 times 95 is 1520. Is that equal to those added? Well, the sum of those is 1521. So this is not a right triangle. So we can use that Pythagorean theorem to decide whether or not it's a right triangle. We can also use it to determine whether it is acute or obtuse. If your value of c squared is less than a squared plus b squared, then the triangle is acute. If your value of c squared is greater than a squared plus b squared, then the triangle is obtuse. So let's look at an example. Decide whether the set of numbers can represent the side lengths of a triangle. We'll talk about that in a minute. If they can, classify the triangles. Now, as far as this, for 3 numbers to be a triangle, any 2 sides must sum or add to be bigger than the third. Any two sides must add up to be bigger than the third. Keep that in mind. So if you look at number 1, think about this. Is 8 plus 18 bigger than 24? Yes. Is 18 plus 24 bigger than 8? Yes. Is 8 plus 24 bigger than 18? Yes. So any two sides is bigger than the third. So this is a triangle. So now we need to see how the biggest side, 24 squared, compares to 8 squared plus 18 squared. How does the biggest side squared compare to the other two sides squared? 24 squared is 576. How does that compare to 64 plus 324? When you add those up, you see that that's 388. So 576 is greater than 388, which means this is obtuse. I want you to take a minute to try the next one on your own. So how does the biggest side squared compare to the other two sides squared? For 5.1 squared is 26.01 compared to the other two squared and added is 33.28. So that c squared is less than the other side, which means this is acute. If you look at the last one, before you jump right to squaring 13, notice what happens if we add 5 and 7. 5 plus 7 is not bigger than 13. So this is not a triangle at all, because 5 plus 7 is not bigger than 13.